I wonder what'll happen if I put magnesium to 6 molar HCl. Let's find out. Wow, would you look at that? A lot of bubbles. Wonder what those bubbles are. Wonder why the magnesium doesn't sink to the bottom. They're just floating on there. Weird. Pretty cool though. Pretty dangerous too. So what's happening when you mix magnesium with hydrochloric acid is a single replacement reaction, which is a type of redox reaction. So we got reduction, we got oxidation. What we're going to need to do is we're going to need to look at what happens to just the magnesium and what happens to just the hydrochloric acid. In order to do that, we need to look at these things called half reactions, which is what this video is going to be about. All right, so topic 12.3, half reactions. What we want to be able to do is write oxidation half reactions and reduction half reactions. So what is a half reaction? Well, if you were to break down redox, it's half of the stuff being reduced and half of the stuff being oxidized. That's the word, redox, half reduction, half oxidation. So a half reaction is looking at just one of those things. It's looking at just what's being reduced or just what's being oxidized. Right? So if, for example, we have this reaction, I already cheated, got all the charges applied. The question may be, well, what's being oxidized? Well, if we take a look, copper is the thing being oxidized. Right? It goes from Cu0 to Cu plus 2. How did it do that? Well, what is oxidation? You got to remember that oxidation is losing electrons. So for copper being oxidized, it went from Cu0 to Cu plus 2. How did it do that? It lost 2 electrons. So where did those electrons go? Did we start with them or did they end up separate? They ended up separate. So that would be copper's half reaction. It started off as a whole thing, but then it became copper plus 2 ion and lost 2 electrons. So if we lost it, it's on the right side. Oxidation, you put the electrons on the right side. Now if we were to take a look at the reduction, well, what was reduced? It was the Ag plus 1 was reduced to Ag0. So let's write that out. I got Ag started as plus 1 and ended up as Ag0. Well, how did it do that? Well, remember that reduction is gaining electrons. So if it went from plus 1 to 0, it must have gained 1 electron, which means the electron is added to the reactants. We started with them separate, and they ended up combined to one thing. So that's the reduction half reaction. Now, one thing we want to be able to check, too, is that first off, elements are balanced on each side, and then the second thing, that charge is balanced on each side. So if we take a look here, copper, we got one on the left, we got one on the right, that's good. Now let's check the charge. Well, I got a charge of 0 on the left side, and I have a plus 2 and 2 minuses. I got 2 electrons each minus 1, so plus 2 and minus 2 gives me a charge of 0 as well. So that's good. All right, well, Ag, I got 1 on the left, I got 1 Ag on the right. So, that's balanced. Now I got to make sure the charge is balanced as well. I got a plus 1 from the 1 Ag on the left, and I also got a 1 minus from the 1 electron. So overall, on the left side, I got a 0, and on the right side, I just got a 0. So charges are balanced. They won't always be 0, but they need to be equal on both sides. Like, for example, it could have been plus 1 overall on the left and plus 1 on the right. That would have been fine, but they need to be equal to each other. All right, so here's another reaction. Let's take a look at this. It's kind of a special reaction, and I'll tell you why. So here are the charges done already. I cheated. So oxidation half reaction. Well, what's being oxidized? Looks like it was, that's a good question. Where's my pen at? Cl minus, right? It went from Cl minus to Cl0, right? This is a special case because it's a Brinkelhoff. Now remember, the Brinkelhoffs come up in pairs, right? If you look up here, it's Cl2. You won't ever have chlorine by itself. Same with bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. They'll never be alone. So when we do our half reaction, we gotta show that. All right, so we start with a chloride ion, Cl minus 1, and it ends up as Cl2. Well, how did that happen? We can't just make a chlorine out of nowhere, right? We got 2 on the right side. We need 2 chloride ions on the left side. So we have 2 chloride ions becoming a chlorine 2 molecule. Well, how did it do that? Well, if it was oxidation, which it is, right, it went up in charge, it lost electrons. Now, how many? Well, let's think about this. It went from -1 to 0, so it's 1 electron for each chlorine. Well, I got 2 chlorines, so I must have lost 2 electrons. Now let's check things, right? First, check to see that your elements are balanced. I got 2 chlorines on the left, and I got 2 chlorines on the right. That's good. Now let's check the overall charge. Well, if I have 2 chloride ions, each has a -1 charge, that tells me I got a -2 on the left. Let's check the right. I got 2 chlorines, 0 charge, but I also have 2 electrons. Each electron's -1. I got a -2 on that side as well. So that is my oxidation half reaction. Now the reduction half reaction, kind of same thing, right? What's reduced? Well, the fluorine was reduced. It started off as F2. It'll never be alone, so I got to draw F2, and it's reduced to become the fluoride ion. But not just one fluoride ion. Since I started with 2, I got to say 2 fluoride ions, right? So now I know reduction is gaining, so I know that it's gaining electrons. But how many? Well, if I go from 0 to 1, that's 1 electron each, and there's 2 fluorine atoms, so they need to gain 2 electrons total. All right, so now let's check. I got 2 fluorines, good. I got 0 and 2 minuses, so that tells me I got -2 on the left side. I got 2 minuses on the right side. Charges are balanced. So, oops. So this is my balanced reduction half reaction. So that was my reduction half reaction, and this was my oxidation half reaction. Right? Not so bad. Just got to be careful of those Brinkelhoffs. So let's try our hand at some practice problems. Feel free to pause it right now. Okay, press play. All right, so now we figure out the charges. Things by themselves are 0. Oxygen's got to be -2. Hydrogen's got to be +1. So now we go, all right, well, what was oxidized? What went up in charge? Well, the hydrogen was oxidized, went from 0 to +1, and it's one of those pesky Brinkelhoffs. So I got to say it's H20. What did it become? Well, it became H plus 1, and I can't just have 1. It's got to be 2 because it's a Brinkelhoff. How did it do that? Well, it lost 1 electron each. So we really lost a total of 2 electrons. So let me check. I got 2 hydrogens on the left, and I got 2 hydrogens on the right. That's good. Now I got to check charge. I got a charge of 0 on the left, and a charge of +2 and -2 on the right, which would equal 0. So charges are balanced. So oxidation half reaction, good to go. Now what was reduced? We started with O2, and that was reduced to become O-2. But again, since I started with a Brinkelhoff, I need to say we end up with 2 oxygen ions. All right, well, now the question is, how did that happen? Well, in order for it to change 2, that's a total of gaining 2 electrons each. Since I have 2 oxygens gaining 2 electrons each, that's a total of 4 electrons being gained. So now let's check. I got 2 oxygens. I got 2 oxygens. I have charge. O2, 0 plus 4 electrons. That gives me a -4 on the left. And 2 -2s gives me -4 on the right. So that's good to go as well. Let's do another one. Ag0, NO3 is -1. Copper by itself is 0. I'm going to have to erase some of this stuff. Give me some room. Copper with 1 nitrate. Well, since the nitrate's -1, I know copper's got to be +1, and Ag by itself is 0. So the thing being oxidized is copper. It went from 0 to +2. So I'm going to write copper 0 became copper +2. It's not a Brinkelhoff, so everything's good to go. Now I go, all right, well, if I went from 0 to +2, how did that happen? Well, I had to lose electrons. How many? 2 electrons. That's how you go from 0 to +2. So now I check. 1 copper, 1 copper, Awesome. I got a 0 charge on the left, and I got a +2 and a -2. So I got a 0 charge on the right. Good to go. All right, well, what was reduced? Well, it looks like looks like I messed up and said AG was 0, but it was really +1, you big dummy. All right, you don't gotta yell. All right, so AG is +1. So it started as AG +1, and it became AG 0. And it did that by gaining electrons, so I know that I got to gain an electron. How many? Well, from +1 to 0, that's just 1 electron. So I check. I got 1 AG, 1 AG. I got +1 and -1. That tells me the charge is 0 on the left and charge is 0 on the right. Good to go. All right, 2 more. So we got iron. By itself is 0 charge. Copper with 2 nitrate ions, each -1, tells me that the copper is +2. Over here, iron is with 2 nitrates, so I know that it must have a +2 charge because each nitrate is -1. Copper by itself is 0. So the thing that's oxidized, the thing that went up in charge, was iron. Went from Fe0 to Fe +2. How did it do that? Well, to go from 0 to 2, it must have lost 2 electrons. So I write 2 electrons on the product side. I check. 1 iron, 1 iron. Awesome. Overall charge, 0 on the left, +2 and -2, 0 on the right. So it's good to go. What was reduced? Well, the copper went from +2 to copper 0. How did it do that? It must have gained 2 electrons. To go from +2 to 0, you got to gain 2 electrons. All right, so I got 1 copper on the left, 1 copper on the right. Overall charge of 0 on the left, because +2 with 2 minuses gives you 0, and 0 on the right. So that is good to go. Check it. All right, and the last one, this is what actually was happening in the video. So we had Mg metal, which is neutral, has no charge, with hydrochloric acid. So +1 for the hydrogen, -1 for the chloride. And I was actually making Mg +2 and chloride ions. So I was making magnesium chloride and hydrogen gas. That's what all those bubbles were. If I were to write or light a match up on top of it, we would get, right? You guys did a lab so long ago where you made some hydrogen gas and then it went whoop. So it's making hydrogen gas. And the reason that the magnesium wouldn't actually sink into the test tube was because as the magnesium was hitting the hydrochloric acid, it was making that gas right there and kind of forcing it up, right? As soon as the magnesium touched, it was making gas underneath it, which was pushing the metal back up, and that's why it would kind of sit there and move a little bit. Pretty cool stuff. All right, so what was oxidized? Well, magnesium was oxidized. It went from 0 to magnesium +2. How did it do that? It lost 2 electrons. Where do those electrons end up going? That's a good question. They just disappear? No. Those electrons were gained by hydrogen that was being reduced. All right, well, hydrogen went from H+ to H2. Oh no, it's a Brinkelhoff again. So that means I got to make sure that, hey, if I end up as H2, I must start it with 2 H+. Right? Well, how did 2 H+ become 0? Well, they each had to gain 1 electron. So they really gained 2 electrons total. So hey, would you look at this? All of these reactions, we have a half reaction losing electrons, and we have a half reaction gaining electrons. So what's actually happening is the electrons are going from magnesium, right? Magnesium has these electrons, and it's losing them to the hydrogens, and the hydrogens are gaining them, right? If only we could somehow make use of that to power like electronic devices. Oh wait, we do, and that's an upcoming topic. All right, so that's all I got. Bring questions. I hope you guys, will get the practice that you need, and say, hey, I need help with this, and I'll help you. All right, see you in class.